Hey everybody, Miss Powers here. If you forgot what my face looks like without a mask, here it is. I am here in my home. I miss you guys very much, but I cannot be there because my whole family has COVID. We tested positive last week, so we're coming to the end of the journey here. I'm feeling better, but just continue to think about us and pray for us if you're that kind of person. Obviously I'm not there, so we're going to be doing notes this way. But I wanted to tell you a couple things. First, I'm a little stuffy from COVID, so just bear with me through the video. And then also, you guys can't answer my questions. If I was there in real life, I'd be asking questions and getting you to talk about the material. So if you have a partner or something you can turn to, just if I ask, like, what does this mean? Maybe just turn to your partner, I'll say, and discuss something with them. And then also, if I ever go too fast or you need to stop the video for any reason, just pause it and then try to catch up. If anybody needs to stop, just tell the person that is projecting, can you please stop for a second so I can catch up? And then you can stop and catch up and then continue on with the video. Okay, you guys know sometimes I go a little fast, sometimes I go a little slow, so it just depends. But anyways, I miss you all. I wish I was there, but this is what we have to do for now. So, with that being said, I do not have a handout for you, obviously. We're just going to do some handwritten notes today, and we're going to be talking about ratios and proportions, which maybe you know a little bit about. It is a middle school standard. We're just going to go ahead and jump right in. First, we're going to define the word ratio. And a ratio is a comparison. A comparison of two numbers by division. So you're comparing two numbers with division. Really quick, turn to a partner, and what is something that has two numbers and division? One word starts with an F. What is that called? Something that has two numbers with division. Hopefully you said a fraction. Okay, a ratio is just another word for a fraction. You have two numbers and you're comparing them with the use of division. So, what's the difference between a ratio and a proportion? We're going to find out. So, proportion is the next word. Proportion. A proportion is actually an equation. An equation stating that two ratios are equivalent. Okay, so, for example, a ratio might be 1/3, okay, or something like that. A ratio is just a fraction. But a proportion is saying that maybe 2/4 is equal to 1/2. You're stating that two ratios are equivalent, and it's an equation, basically. So, this is two ratios instead of just one. That is a proportion. So, first example, the directions are determine if the following ratios are equal. So, they're going to give us two different fractions, and we have to determine if they're equal. So, part A, oh, I forgot to put example 1. Part A, we have 8/14 and 12/28. So, how are we going to determine if these two ratios are equivalent? There's actually 3 ways we can do it. So, way number 1, and you don't have to do all 3. I'm going to show you all 3, and then whenever you do this, you can just pick whichever one you like better. Number 1 is to do it by dividing the numbers out into decimal points. So, 8/14 divided out is 0.571, and it goes on forever, but that's just me rounding. And 12/28, whoop, low power, 12 over 28 is 0.429 approximately. So already we can tell these are not equivalent. So that's the first way to do that. I just write no. The second way, and remember, you do not have to do all three. I'm just going to show you all three. And then whenever you do it, you can pick the one you like. Second one is to reduce the fractions. So here are our two fractions. Reducing them means trying to get them as low as they can go. So basically, what's a number that can go into both 8 and 14? Well, 2, right? So if you divide the top by 2 and you divide the bottom by 2, 8 divided by 2 is 4, and 14 divided by 2 is 7. Then we do the same thing on the bottom, and if they're equivalent, it would also be 4 over 7. But let's see. When you do the bottom one, you don't have to pick the same number. You don't have to pick 2 to divide it. You just pick a different number. So what is a number that can go into 12 and 28? 2 can, but is there a bigger number? What about 4? I think 4 will go into both of those. So let's divide by 4 here and see what we get. Here it's 3 on top and 7 on bottom. So again, no, these are not equivalent. And the last way is something that I call cross multiplication, but in the book they call it means and extremes. And we are going to use this coming up, so you do need to be familiar with this one. This time you put them kind of side by side in like a little proportion, although we know they're not equal, but we're just going to find out if they are. And this is where we like to use our butterfly wings. So these might be familiar from middle school. You butterfly wing across, and we're going to multiply. Then a different color, butterfly wing across, and multiply. So I'm going to do my blue first. 8 times 28 is 224. Okay, and 14 times 12 is 168. So those are not equivalent. No, and that is how you determine if ratios are equivalent. So that was a no example. I'm going to do a yes example for you, and then we'll move on. Part B. Part B, we're going to use the fractions 3 over 10 and 12 over 40. So I already told you these are equivalent, but let's do the 3 methods and prove it. 3 divided by 10 is 0.3. Goodness, that 0 was bad. Okay, 0.3. And 12 divided by 40 is also 0.3. So this one is a yes. They are equivalent. So then method number 2. Divide and simplify. All right, 3 over 10 doesn't reduce anymore. It is as far down as it can go. So I'm just going to write it how it is there. However, 12 divided by 40 can reduce. So what's a number that goes into 12 and goes into 40? It is 4. So let's divide by 4, and we have 3 over 10. So, yes, they reduce down to the same number. They are equivalent. And method number 3, means and extremes. 3 over 10 equals 12 over 40. Get your colors out. Cross multiply. 10 times 12 is 120. And then my other color, green, 3 times 40 is also 120. So again, we have a yes here. So whichever method you like the best and works for you, you can use that. Although we are going to be using the cross multiplication coming up. So just that I would let you know. Hopefully there are no questions, but if there are, ask your neighbor. So coming up, those directions were just determine if they are equal or not. So you just say yes or no. This time, we're going to solve a proportion. So this is example 2. Did I underline the first one? No, I didn't. Okay. These directions are solve for x. All right. So part A, we're going to start off easy here. X over 10 equals 3 over 5. So, could you say, oh, times 2, it's 6? Yes, you can. These ones are a little more easy. However, they do get harder, so I'm just going to show you the same method for all of it. We're going to use means and extremes, the cross, butterfly, whatever, I call it butterfly. We're going to use the same method, but yes, you can do that with some of the easier ones. But let me show you what I'm talking about here. So, multiply with the blue. So, 5 times x is 5x. Then, multiply with the green. 3 times 10 equals 30. Then, we just solve this equation. So, I would just divide by 5, and x equals 6. Okay, these are more easy. Okay, but like I said, they will get harder. All right, so part B. This time we have x plus 4 over 12 equals 3 over 4. So this time on the bottom we're multiplying by 3, but multiplying by 3 on the top gets a little weird. So here what we're going to do is we're going to cross product. 4 times x plus 4. Put the 4 on the outside, and then x plus 4 goes on the inside of some parentheses. And you know what we do when we have a number on the outside to parentheses. We're going to distribute that coming up in just a minute. Then the 12 goes to the 3, and 12 times 3 is 36. So then we distribute 4 times x, 4x. 4 times 4, 16 equals 36. And then we solve this equation. So minus 16, cancel. 4x equals, what, 20? And then divide by 4, and x equals 5. So you can see how with the easy ones, it's very easy to figure it out. What did you multiply on the bottom? And then just multiply on the top. But with some of these harder ones, it's a little difficult to do that. If you have a different method, go for it. But this is the method that we're teaching today. Okay, and part C for this one. Then we'll do one more example. Part C gets a little more difficult. All right, we got 3x minus 3 on the top over 9. And that equals 5x plus 5, over 3. We're going to use the same method for this one as well. So butterfly the blue here, 3 out in front, times 3x minus 3 equals, then the green, 9 out in front, times 5x plus 5, and close your parenthesis. Then we distribute. 3 times 3x is 9x. Oh, I think I messed up. Yep, this 3 right here is supposed to be a 9. That's my bad, I'm so sorry. 9 right here, 9x minus 3. 9x minus 3. You guys know I always have to make some mistakes somewhere. Every single time. All right, so 3 times 9 is 27x. There we go. And 3 times -3 is -9. Then we distribute on the other side as well. 9 times 5 is 45x. 9 times 5 is 45. From here, you can do whatever you want. I'm just going to go ahead and do my x's first, but it doesn't matter. You can add the 9, whatever you want to do. I'm going to go ahead and subtract 45x. Subtract 45x. Whoa. (27 minus 45x is -18x. Now that I'm looking at my example, I'm like, why did I do it this way? But whatever. Now we can add our 9. Add the 9. Cancel. -18 comes down. Don't forget the negative. 45 plus 9 is 54. And divide by -18. 54 divided by -18 is -3. All right, so not difficult per se. All you got to know is how to solve equations from Algebra 1. So hopefully this isn't too bad. I'm going to do one more example with you, and that is a word problem. These are all over standardized tests. You know I'm trying to get you ready for standardized tests. And unfortunately, I am going to make you write it out. But it's not that bad, I promise. So, here we go. In the past, 2 years, a retailer has opened 232 stores. In the past, a retailer has opened 232 stores. If that rate remains constant, oops. How many stores? If that rate remains constant, how many stores will open in the next 3 years? Now, I know you smarties can figure out a simple way to do this, but we're going to do the method that we have still always done. So basically what we're going to do is we're going to put the information that we know that they give us in one fraction, and the information that we want to know in another fraction, and set them equal to each other. So what do they tell us? What do we know? In the past 2 years, he's opened 232 stores. So in 2 years, this is what we know. He's opened 232 stores. And I like to label, and I'll show you why in just a minute. Now, the question says, how many stores will he open in 3 years? So you might want to put X on the top and 3 on the bottom, but no, we can't do that. The reason why I labeled on the left is because you have to put them in the same order that you do on the left. So if I put years on top on the left, I have to put years on top on the right. Okay, so 3 years, how many stores? X stores. So really just set it up on the left, what they tell you, what you know, and then on the right, what do you want to figure out, and make sure it's in the same place. So years on top, years on top. Okay, now we're ready to butterfly. 2 times X is 2X. And the green, 232 times 3 is 696. And then we just divide by 2. And that would be I think it's 348, but I could be wrong. 348 stores. That's what we're going to go with. So that is how you set up a word problem for ratios and proportions. I don't believe you have an assignment today, but you will have probably a puzzle piece tomorrow. So that is it from me. I hope you guys have a great day.